Is your construction project running behind schedule? Find out why. In this video, I'm going to show you why your project schedule is running behind and what to do about it. So would you like to know why projects in general get behind? What you can do to speed them up? And the principles behind it. If you do, I think you're going to love this video. So stay with us. Okay, so I'm going to give you a quote as we start out, and I think you're going to love the content here. It's absolutely fantastic. It's not about pushing work. Pushing work will not make the project go faster. It's all about making work ready. Let me say that again. Pushing work will not make it go faster. It's all about making work ready. So there's this concept that I want to talk to you about, and it's called the Bungee effect. And we have mentioned it in other videos that I do, but I'm going to mention it again here. And let's take this example in a time by location format, because that's the way we can visualize things. And let's say you have 3 zones. So 1, 2, and 3. Let's say that you have wagon number 1 or trade number 1. That's not an exact correlation. Really, wagons can have multiple trades, but stay with me, please. So you have wagon number 1, 2, and you have number 3. Let's say that in the course of work, there was a delay right over here. And wagon number 2 delayed, which is also going to extend wagon number 3 as well. But let's say that instead of cascading that delay, you thought, like most construction managers, hey, what I'll just do is I'll just stack this work on top of itself, and it's not going to be a big deal. We're probably going to be able to do that work. So if I color that, actually I'll color it with blue. Let's say that this second trade, this was the blue wagon, and this is the blue, okay? Now you've got work, it's actually called burdened. When you have one trade in too many areas, that's called trade burdening. When you have too many trades in one zone or one area, that's called trade stacking. So this is actually called trade burdening. People in construction typically think that this is okay because, you know, forget it, like the crew can just go ahead and magically do new work. Well, that's actually not the case, because when you have a situation like this, you start to add resources, okay? And I'm going to just briefly discuss this as we go. Once you add resources, you start batching. That means that you, instead of doing one thing at a time, are now doing multiple things. When you start batching, now you have context switching. Okay? And when you have context switching, that means that you add 15 to 45 minutes minimum to each task when you go back and forth because you're not focused. The other thing that you do is you have larger teams, and when you have larger teams, because you've added resources, okay? When you have larger teams, that equals communication complexity. So I like to go ahead and draw it like this. If you have 4 people on a team, that's 1, 2, 3, 4, 5, 6 communication channels. If you even just did 6, just from a relative example standpoint, this is going to be hard for me because it's so much. You got 1, 2, 3, 4, 5. You have got 6, 7, 8, 9. You've got 10, 11, 12. 13, 14, 15. So this was 4 and 6, and this is 6 and 15, right? I think I got that right. But anyway, you can see that as this becomes incremental, this becomes exponential with an E, and your communication gets really complex. The other thing is you change the crew composition. So that's number 4. If you had a foreman and workers, now you're changing these out and bringing new people in. You have number 5, which is called onboarding. The problem with this is that it takes 7 days to onboard new people to full productivity. Until you have total onboarding, you start to work overtime. Overtime is a problem because after week 6, you start to fatigue the crew earlier on, but you fatigue them to a point where they lose productivity. At week 9, it becomes an exponential loss. So then the workers are tired. Once they're tired, then you have a lack of focus on quality. So now you have rework. And when you have rework, now you are spending anywhere from 2 to 12 times the original duration and cost to fix things, and now you have stopped planning, which means that you have roadblocks and stops and restarts. So there's actually more to it, but the bottom line is when you do this and you add resources, you start to have all of these negative effects from a productivity standpoint. And so what we should have done was literally, instead of holding this third zone like this, we should have just cascaded that out. So I'm going to draw it the way that it should have happened. We should have cascaded that out to where we absorbed that and we had a nice flow from there to the impact to here, because we had buffers at the end that we could use. And that trade flow is the single most important thing in construction from a productivity standpoint. So this is called the Bungee effect. Now, if you're like, Jason, I don't believe you, I don't believe these things, then check this out. People will say, yeah, adding more people obviously makes the work go faster. No, it doesn't. Because if you have a duration for an activity, let's say that it's 4 days. Let's say that it legitimately takes 4 days. The activity probably only takes probably 3.5. But you have additional time in there for what's called variation with a V and productivity loss, which I'll note with PL. So you have the activity, the variation you have, and your productivity loss. This is a representation of what happens. So check this out, everybody. If you're like, hey, I've got a task and I want it to go faster, and this is my activity time, okay, and I've got a small amount of variation and I've got a small amount of productivity loss, I'm going to go add people to it, add labor, because I'm doing this trade burdening. And you're like, of course, Jason, the activity time gets smaller, right? You can see that this box is smaller than this. What people don't understand is that your variation and your productivity loss, which comes from here, so I'll just write this as PL, gives you a net loss, and your overall time, instead of being 4, could end up being, even though the activity time is shorter, this could be end up being 4.5 or 5 days. This is called the Bungee effect. Instead of pulling it back, it'll bungee out, it'll spring out on you. And so this is a production principle that we have to know, especially when it comes to making sure that our construction projects work well. And so if you're still not convinced, I'm going to show you 3 different things. There's a relationship between capacity, utilization, cycle time, and work in process, and overall throughput time. All of these things have a correlation. And I'm going to simplify all this down. I got this from the book Built to Fail, and then also from the book This is Lean by Nicholas Modig and Par Ahlstrom, but I'm going to simplify this for you. So the concept that the more people you add, or the faster you go, that equals more work is false, okay? This is false. I'm going to put an X through it right here, is because of these different things. Let's take a freeway example, and let's talk about cycle time. So when you have a freeway and you have the fast lane, and then you have your middle lanes and your slow lanes, if you have an off-ramp and an on-ramp, and you have high utilization in the fast lane, and you have variation coming from this affects the overall flow of the freeway. So let's look at concept number 1, is that if you actually increase utilization, meaning that you are going beyond the capacity of the freeway, and you have quite a few cars in here, and they're all stacked, okay, and it's highly utilized. You've got a lot of people in the fast lane, and you've got a lot of people coming on the freeway, and you have probably exceeded the capacity here. When you look at this from an overall standpoint, and you can see this in traffic patterns, when you have high utilization, the cycle time, which is the amount of time it takes to get one thing done from start to finish, let's say your car to go from your home onto the freeway and then get to the next off-ramp and go to work, the more utilization you have here, the longer your cycle time is, meaning this will get longer. And that's what people don't understand, is they're like, okay, let's rush and push, let's make workers go faster, and let's put more people to it. That doesn't equal more work being done, because cycle times increase. The more utilization, the more of something you have, the faster they go, to try and rush and push and panic, the longer it'll take you to get work. So that's one representation. The second one is that if you have an accident, so let's say over here, there's an accident and you've actually not got just the cars, but you've got a pileup of cars, and there's an accident and a crash, and you've got like police officers on the scene. You can put more people and you can ask them to go fast, but this system will not go any faster than your actual bottleneck, right? And so your work in process cannot be greater, meaning it cannot be greater than your actual bottleneck, okay? So you have to understand that, yeah, you can rush and push and panic, but it's not going to do you any good. It's like having a kinked hose. Is putting more water pressure on that hose going to make it flow? No, removing the kink will. The third relationship is talking about the increase of work in process and the overall throughput time. So from a general standpoint, throughput is how many of these cars can we get through this freeway in a certain amount of time. It's not the individual cycle time any longer. So as work in process increases, that means that the overall batch or the throughput time will extend. So it's not just utilization increases your individual cycle time, it's that the more work and process, more cars on the freeway will extend the throughput of the overall freeway. It's just like people would naturally think having high blood pressure helps with circulation. Actually it doesn't, and it's hard to draw blood because it actually slows things down and creates congestion. So the problem here is when you're looking at construction schedules and you've got your crazy old CPM schedule that's like all bunched up, the forward and the backward pass is bunching it all up to get it to its early start. You have if I'm doing a histogram, you've got a high level of work in process here, right? This high level above capacity is only going to extend your cycle times. It won't be able to go any faster than your bottleneck. And this increase in work in process will only extend your overall throughput. So this schedule is going to go like this and finish late. And that's why projects get behind. So you have to keep these three things in mind. Is again, the more your utilization goes above your capacity, the more you push into bottlenecks that aren't removed, and the more work in process that you have, the longer your throughput times are. Show you that CPM and measurement techniques like EVM, which incentivize you to spend more money faster, are bad because they only extend your overall total project duration. So what you should be doing is having a nice, good production schedule, leveling out your work, managing and controlling your work in process, and understanding your cycle times, understanding your throughput, and making sure you're not going past your capacity from a utilization standpoint. This is a pretty hard concept. I'm going to give you a Canva graphic in the description below. This is why projects start to run behind schedule. It's not typically just, oh, I missed the materials or our workforce sucks, which is not true. It's not the typical things that you think. It's the Bungee effect, and it's us not understanding this concept, rushing, pushing, and panicking, and adding more people, which gives us the Bungee effect, not only with the labor itself, but with these overall concepts. I hope you've enjoyed this video. On we go.